Hi, it's Ftrhstry, talking 2020s from the 2120s, talking Jupiter today. Gonna get a big picture overview. Why? Because Jupiter is Daddy. In both the colloquial sense from the 2020s, in which Daddy is like a cool older person, maybe identifying as male-ish, and in the historical, sort of metaphorical sense of a paternal, protective figure. Jupiter is the first planet to have formed in our solar system, and it's big enough that it protected many of the other smaller planets from nasty little smashies from the Oort cloud for many years. So it's possible that we exist in the first place because Jupiter was out there just running field for us, stopping all the whammy-bammies, or, many of the whammy-bammies, enough of them, to get us out on top post-dinosaur. So it's really cool because of that. But it's also cool because it's just big. It's one of the most interesting, awesome objects in our nearby vicinity. To get a picture of how big it is, most of the solar system is the sun, right? Like 99.86% of the mass in the solar system is just the sun. 99.86% of the mass of the whole system, just the sun. Of the remaining 0.14%, almost 70% of that is Jupiter, like 67.86%, something like that. Most of it, Jupiter. Think of that. Nearly 100% of the mass in the solar system, the sun, 70% of everything else, Jupiter. That's more than everything else put together twice. It's really big. Okay, point achieved. And because it's so big, it's got a staggering amount of little things whizzing around it, like 75 plus moons. And that's just the ones discovered in the 2020s. By the 2120s, we know about more moons, but most of them are smaller than the ones we know now. You know now. Ganymede, Callisto, Europa, and Io are the four biggie baddie goodies of the set. They're all roughly the size of Earth's moon, and three of them have underwater oceans: Europa, Callisto, and Ganymede. Very interesting, isn't that? Isn't that appealing? Don't you just want a vacation today? We'll talk about how hot or not those are in a moment. There's a lot of ice involved. The fourth moon, by the way, is extremely blowy-uppy. That's what makes Io fun. It's by far the most active volcanic area of the solar system, like more even than Earth, to the point that there's flowing silicate lava just like all over the place on Io. It's a hot mess, but because it's spewing so much stuff up, it's contributing radioactive energy to the magnetosphere of Jupiter, which is enormous. Arguably, it's the largest structure in the solar system. The magnetosphere of Jupiter is 12 times the width of the sun, which, as we discussed earlier, is already pretty big. So 12 times the width of the sun, just like bubbling out. It's getting buffeted by the sun. The solar winds are pushing the magnetosphere of Jupiter all the way out to Saturn at the edge of its tail. Saturn, by the way, the next biggest thing, coming in with like around 20% of the remainder post-sun mass. So Jupiter and Saturn together, like roughly 90% of the non-solar mass of the solar system. What else to tell you about Jupiter? Okay, just the name, please, like nameplate stuff. Well, I guess technically the name is from the Roman god Jupiter, who's named after he was like a reincarnation of the Greek god Zeus. And the word Jove is sort of like a shortening of Jupiter, so like a Jovian day, which happens to be 10 hours, is a day on Jupiter. So very short day, like 2 Jovian days per 1 Earth day, but then a Jovian year is quite long. It takes about 12 Earth years for Jupiter to circle the sun. It's about 5 astronomical units away from the sun, which is 5 times Earth's distance from the sun. And it's the 5th planet out from the sun. Jupiter, right? And it's kind of the gateway to the rest of the solar system. In my time, in the 2120s, that's the role that it's starting to play. It's like the intermediary between the grey beyond and the inner system. The atmosphere is mostly hydrogen and helium, with a little ammonia, a little bit of water. And what's really fun about this atmosphere is that as it gets squished down toward the middle, the atoms get so dense that there's like a liquid hydrogen core that's like so squishy dishy, it's like actually like a metal, like a liquid metal. And in that squishing process, electrons are released that then fly up and contribute to the magnetosphere of Jupiter, and it's like fairly intense radiation. Can you imagine the pressure it would take to squeeze out an electron? It's a lot of pressure. Under that, in the 2020s, the theory goes, there's a rocky center to Jupiter, like roughly the size of Earth. Extremely dense, obviously, because it's getting frozen in the middle by all those incredible planetary forces. And then outside of that is the liquid metal surrounding. It's hydrogen. I believe it's hydrogen. Could be the helium, but it's liquid metal. And the core itself is a bit wobbly. Theory goes that it might have been smashed like by a direct collision in the early formative days of the solar system. It's possible that that's why it's still jiggling, a little wobbly. While it was playing the field for us, it took some hits. So why is this interesting in the future? Jupiter is interesting in the future because it's a locus of activity. It's like much more populous, for one thing, than it is in the 2020s, like when no one's there. In the 2120s, there are people there, like actual, whatever, classic edition, biological people, but lots of digital intelligence too. There are lots of active intelligence in servers all over the system there. Big research outposts, like outposts on all 4 of the Galilean moons, because of course we've got to check out those oceans and the splody volcanoes, but then lots of the other moons too, and then some orbital stuff, obviously, to keep an eye on what's going on, like scientific investigations, checking out those storms. The red spot on Jupiter, you've probably seen it's like its most distinctive beauty mark. That red spot is bigger than Earth. It's like 2 to 3 times as wide as Earth, and like Earth could fit in that spot. And what that spot is a freaking storm, and it's been raging for like hundreds of years, to the point that like as far back as human records go of Jupiter, this storm has been on it, ladies and gentlemen, and it's so rocking and all rolling that the gravitational waves emitted by this storm, in combination with the acoustic waves from it rocking so hard, actually smash together in the atmosphere to generate heat. And we think that's one of the reasons that the atmosphere is hotter than it otherwise would be, just based on sun reflection. It's not very hot overall, like the average temperature on Jupiter, all things considered, is like negative 240, but is spewing a lot of radiation, has a really dense radiative torus, or like really radioactive torus around it, which is like a donut shape. If you're not familiar with tori, all planets have something like this, but Jupiter's is like especially strong, partially because Io's out there spewing crazy stuff into it, and partially because these electrons are getting squeezed out of the liquid metal around the core, and partially because it's so big. Lots of stuff happening in these storms. The storms all over the planet, forming cool hexagons. That's another thing you might want to look up. And like long streaks, and they come and they go. Some of them stay for decades or hundreds of years. And so that makes it a really active, really interesting place. And I think that's at the core of why it's such a hot destination, even in the 2120s. It's starting to pop off. It's still like relatively nascent, the civilization there. But it's just so interesting that it's hard not to imagine it becoming a major cultural and socio-political center of the solar system that we currently share and love. And in the very long run, it might come in second only to the Dyson sphere around the sun that's controlling the power of the solar system. Maybe we'll talk about that another time. And of course, Earth is still in the mix. In the 2120s, Earth is still primo socio-culturally and politically for the solar system. But in the long run, I could see, projecting forward from my time of the 2120s, Earth sort of fading into more of like an Egypt cradle of civilization role, which is like cool, or like Rome or ancient China. Like, no, these are interesting places, but they're not, where the beating heart is. So it's possible that Jupiter could become that beating heart just because there's so much interesting stuff, and because there's, some rampant commercial activity in the German atmosphere. Excuse me, I just said German and meant Jupiterian. Not sure what has me thinking about the engineering powerhouse of Middle Europe. I suppose in the 2020s it's having a bit of a tough go. But out in the 2120s, they're doing better. Europe is largely fine. That's also for another time. Jupiter is a heavy commercial sector in the 2120s because of deuterium largely. It's an excellent source of fusion fuel. So it's a good place to mine that because there's just so much hydrogen in the atmosphere of Jupiter that you can pick up this deuterium, which is a stable isotope of hydrogen, along with protium. It's the only other stable one, and it's the most popular, at least in the early days of fusion, fuel to smash together and make energy. And that's important because as far away from the sun as Jupiter is, it doesn't have a ton of solar energy like, say, we can get on Earth. Pretty good solar power. On Jupiter and farther out especially, you're going to need like a localized source of energy. So fusion becomes quite valuable, and deuterium is therefore a very useful substance, hence the commercial activity in the atmosphere of Jupiter. What else have I got to tell you? Not really all that much. Jupiter's very special. I think we should go there together and have a nice vacation. Look into some hydrogen or helium. We'll come back around and talk Europa, Io, Callisto, Ganymede, probably one by one. 75 moons, second only to the sun. I think we've done it. Jupiter rocks. Jupiter's daddy. You can be too. Daddy out.